to the shore, so they're already safe. Just got the boat.
Here we have a situation where a canoe is wrapped. A wrapped canoe is where it gets sucked underwater and folds around in whatever format around an obstacle, whether it be a tree root system, a tree, a rock. This is quite a common occurrence on canoeing trips. As a guide, priority would be to get the participants out of the canoe, which they would have naturally fallen out. You want to do a head count to make sure there's no one stuck under the boat. You want to make sure you've accounted for the people that were meant to be in there. The equipment's probably floated out by now and floated downstream, so that would be another priority. So first priority is safety of yourself as the guide, then the safety of the participants, and then equipment. So if you've got numerous people around, you can utilise them to help go and recover the paddles, barrels, water bottles, etc. So in this situation, our next objective is to get the canoe off the wrap. This one's been placed here deliberately by the trainer, so it's not a very solid wrap. You could just walk out and just push it and it'd come off. But for the training activity, this is what we're looking at. The thing I'm looking for as a guide on the trip is on how to get it off. So I'm looking for the volume of water on the boat and where most of the volume is, and also the angle of the boat. So where I'm standing here, that angle there is the natural angle of the current. So that's 90 degrees to the riverbank. We'll notice the left-hand side of the boat here is at a downward angle, more downstream than the top side there, which is at a higher angle. So theoretically, the more angle downstream, this side here on the left would be more efficient to take it away this side. However, the majority of the flow is on the river right hand side. So it's a bit of a 50-50 at the moment. If it wasn't at that sort of angle in relation to the riverbank or the current, I would be considering taking it off to this side here, river left. So the students have now identified that the most of the flow is on the river right hand side as we're looking at it. So we can either manoeuvre it off with our hands. So what they're doing now is wiggling the boat. That will determine on how much play it's got. So by moving it up like that, we'll get the left-hand side of the boat, the river left-hand side here, up out of the water, reducing the amount of drag on this left-hand side and increasing the drag on the river right-hand side. That will allow it to come off. So what they're doing now, they're bouncing it. It's slowly moving further to the right. The further it heads to the right, the more drag it has. So they're choosing to do this wrap here just by hands. We have trained them to utilise rope systems and mechanical advantage and how to roll it. So what they've achieved now is quite good. Their objective would be to keep trying to push it further to the right hand side rather than twisting it. Okay, instead of twisting it as in a clock face, you want to push it out into the current further. Okay, the further they twist it, the more of the river left hand side gets affected by the current. So we want to move the central pivot point. The pivot point now is the tree root system on the boat. Okay, we need to push it further to river right. Another thing they've done here is one of the staff have jumped out onto the river right hand side of the boat, further increasing the drag on the boat, which is a possibility of assistance. So that's her alone out there is enough to drag, and that's also pulling the pivot point further towards river right. So now they've got it off. That was an effective recovery. A real easy recovery. This water's not high pressure, and there's quite an easy one to get off for them. This is another planned wrap. We're running a training activity for some new students. Andrew's deliberately placed the raft there in a wrapped position. So Andrew's standing on top of a root system, and that root system is in the middle of the river. So the canoe is currently stuck there. He's balanced it out evenly, so both sides have about the same sort of pressure on it. It's fully submerged with the cockpit facing upstream, so there's a lot of pressure on the boat holding it down and towards the root system. To me, the only way to get this one off, it's quite powerful water, and that would be to set up a roping system. So tossing up which way you're going to do it, I'm also looking at the access on River Right. It's very poor access over there to set up roping systems. And over here on River Left, we've got very nice footing, rocks, shallow, and lots of trees to anchor off. So for me, I would be considering getting the canoe to be pulled this direction towards River Left. To do that, I would possibly have to get a rope on the far River Right side around the carry hold, put a rope on there and set up a mechanical advantage. Which direction? I'd probably say a 45-degree angle towards the bank here to set it up. Possibly a 2-to-1, a 3-to-1 will probably be the best one for this. Let's see what they do. Guide 1 and 2, which is the white helmet on the left and the blue helmet in the middle. They chose to shallow watercross out to this kayak. Shallow water crossings can be used to access sections of the river. It's part of the general rescue training package we teach, and they chose to do that. They did a modified version. They didn't use any paddles. They just sort of held each other and supported each other to walk across. The deepest point it got to them was about the groin in depth. They made it over there quite comfortably. Where they're all standing now is inside an eddy, calm water. So here they're discussing options to get it out, and well, let's see what they do from there. So one of the options we've got for getting a canoe out of a wrap is we can try and roll the canoe like a pencil in water. So we've got to use the roping system to click onto one of the thwarts, which is the little cross beams on the top of the boat, and it's got to go under the boat and then all the way back around the back side, the bottom of the boat, and that allows it to roll. The rolling assists in emptying the water out as it comes up. So the rolling method's really good. So this guy's got to somehow connect onto one of the crossbeam thwarts and then come under the bottom of the boat, back onto the downstream side and over. It's really awkward. And he's able to do that. He's now gone fully under the boat. He's now joining that rope across one of the thwarts. Because we're rolling at that angle, we're in a rolling position, we kind of want to sort of pull more directly upstream rather than off to a 90-degree angle to the riverbank. But a 45-degree angle will probably work effective as well because it pulls it to river left. Pulls it to river left as well as rolling the canoe over. These type of wraps can also damage the keelson of the boat, which is like a little bracing on the bottom of the floor that's fiberglass or similar. So these generally get broken when they're doing this. So over there on River Left, there should be people setting up anchor systems, and we'll suss that out now. This team's chose to connect the rope onto the river left-hand side of the canoe, which is roughly where the guy in the water is in the white helmet down here. They're planning on just manually, physically manhandling it off using a rope. May work. Again, you've got to try different options. You gradually escalate your options from wiggling the boat just by your hands only to then setting up a rope system, pulling on the rope system, setting up mechanical advantage, and then setting up multiple mechanical advantage systems to do the canoe. So plenty of options here in canoeing to try and get them off. See how this method goes. Just going to pause for a second and come back into it. So now they're about to start pulling. They've got 3 people. So an average person will pull about 50 kilos each. So at the moment they've got 3 people on it. So their pulling power is 150 kilograms, which is a 1-to-1 mechanical advantage. 1-to-1. So the sheer force of that canoe on that wedge is holding it really solid. The simple wiggling, and it's off. So that worked well. There's going to be a lot of weight in this boat now. So the fact that it's anchored onto the rope, they're able to secure the boat safely when it came off. So good job by all.